Well, I want to give you a brief demo of how this project turned out. You can see the final assembly here. You can see the radial arrangement of the 9 coils on the backboard. Backboard has a spacer to keep the coils in the proper alignment with the magnetic rotor inside the canister there. The housing. At the back, you've got some nylon polypropylene supports to prevent the rear bearing from being pushed backwards. Keep everything in position. The wiring, top wiring is being protected with Tygon tubing for those wires that are kind of exposed along the top of the backboard there. You got the 3 phases are separated with color coding. You got 3 of each, 1 of each phase here, and then another 3 down there. And there's coils underneath where you can't see them there. Turn this around. See the front end. There's the gear drive. .24mm socket being used to drive the nut on the shaft. In the back there, probably can't see it. Down the back, there is a cluster of 3 wires. Which are the free ends of the one end of the 3 phases twisted together. That's the ground reference, and the other 3 ends are separately joined at the front to this 6 diode bridge. So each of the 3 leads there goes to a separate center diode path. Okay, so that all the AC energy being produced by the generator is being separated into positive and negative charge. So your DC leads are here and here, connected with a capacitor, which I've chosen as 470 microfarads and 63 volts. Okay. These orange plastic sleeves are at either end, and they're providing alignment support between the ends of the bearing and the ends of the PVC connector to keep the it helps keep the 2 end bearings aligned so that the rotor is kept an even distance from the interior diameter of the housing. I'm going to try to fire it up here. Right at the moment the output is connected to a DMM, which is on DC volts right now. There's no load connected, so what's being produced is open circuit. And gets to 50 volts, and it holds it for a short period of time because of the capacitor. So 50 volts DC from hand cranking on this winch drive, a reverse engineered winch drive. Normally when you buy the winch, the handle is on the small gear and it gears down for tightening the cable on the winch. But here I wanted to turn the large gear and get a speed up effect of 4:1 ratio, which is what we're getting. Now, if you want to see this producing actual electricity to a load, I'll connect this 12-volt incandescent bulb to the system. Slight discharge from the capacitor there. Okay. See the bulb lighting up. And while that's happening, you can see how the meter is about almost 20 volts. 20 volts there. Okay, so I just disconnect that bulb, and just to give you an idea that it can have a practical usage, I'm going to connect up this thing to the positive end. It's already connected on the negative. And I'm just going to go grab a cell phone, which is going to be connected to this. This unit is a automotive cigarette lighter adapter charger for my cell phone. It's an old Pantech. And that's hooked up, so and you can see when I start it up, the charging light is on. The cell phone charging indicator still showing charging. And it does indeed charge, because other measurements I've made have indicate that the jack is receiving 5.3 volts steady. It has an internal voltage regulation, so that the variable voltage that you're producing at the outputs of the bridge, because of your variable cranking speed, don't harm it, because the output is constant 5.3 volts, and about 250 milliamps is what goes in there. So yes, it does charge a cell phone if you want, and it will also charge a larger battery with what seems to be about 600 milliamps of charging current. Okay, and that's it.